one of the terminal already set SMU3, okay, and then the other is SMU4. That's connected to the wafer, the back side of the wafer. Okay, that means the truck, and that is the ground actually. And then if you already know that it's already the ground, so we can simply put the name V ground. Okay, current. Okay, you still have to give a current name for that. Okay. So for the mode, because you already set to ground and you don't need to set any voltage for that, because ground is already at 0. Okay, then you, as you can see, there's an option. There's an option there is common. Okay, there's a common ground, so you can simply choose that. And function, because it won't change, so you choose a constant. Okay, so the both channel are already set. So that's it for this page, channel definition. And then go to the next page is the measurement setup. Oh, what's that? Undefined. Oh, okay, there's a previous setting. I delete that first. Okay, channel definition. As you can see, previously we said SMU3 is the function for that is a VAR1. Okay, so you could see the VA already put the SMU3 into the VAR1 column. Okay, right now we have to set the measurement range. Okay, for the start one, -1.
Let's start from the reverse bias and then go into the forward bias.
Okay.
Yeah.
Then we go to start from 5 then.
Yep.
And in the end will be the -1. Where's the minus? Okay, -1. Okay, and the delta is 0.1.
0.1.
Okay, 0.1 volt. I should input a -0.1. What is this? Out of range. Oh, okay, sorry.
0.
Okay. So because imperiously, okay, be careful about that. When the cursor is go to a particular field, okay, and somehow it will show that value in the bottom of the screen. If there's a value there, you will have to, for your own sake, you have to delete it first. Clear it first, and then enter your desired value, -0.1, and then press enter. Okay, so right now the total number of points is 61. Okay, and the other is compliance. That means current output and limited current output. Right now, the machine itself, the maximum output current is only 100 milliamp. Okay, of course you can make it less. Okay, to protect your sample. Okay. Point is okay?
Yeah, compliance, right? That's important actually. What compliance means actually is that when it's doing measurement, and if for whatever reason actually that for whatever reason actually, let's say the current is very high and the voltage is kind of high, right? So in that case, it will output a pretty big power actually. So there's a possibility that you will burn the device or something will happen actually. In this case, actually, if you're inputting voltage and then the current is coming out, you can put a compliance there, which basically just means you will clamp the current. It will not allow the current to go above that value. That's compliance, actually. This compliance actually for the dial measurement, probably is not too much of a problem actually. But if you're measuring, for example, a transistor actually, and you will not expect the gate current to be very high actually. Right. In that case, you can set a compliance on the gate current so that even if the gate leaks, actually, your devices will not be burned. Essentially, that's what it is. Even in this case, for the dial measurement, you can put a compliance there. Let's say, we can try to put a compliance there. Let's try to put compliance of, let's say, 10 milliamp. I don't think the current will ever go to actually that high. You can put a compliance of 10 milliamp there. Then 10 milliamp will be clamped. If it goes above 10 milliamp, it will clamp it. It will not allow it to go above 10 milliamp essentially. All right, so then we have a compliance there. All right. So if you look at this whole page here, you will now see that whatever we have mentioned before, in terms of the scanning range, the size, and everything is there already, right? Is there anything that needs to be defined?
The sweep mode single.
Okay, sweep then. All right.
Okay.
To use the single sweep.
You use a
mode.
single. Single means from start to stop, and then after that you will stop the measurement. Okay, there's a double there. If you choose double, then after the single direction, and then you go
Return.
back from the end side to the start point again.
Right. The reverse sweep actually is important if you expect to see, for example, hysteresis in your IV measurement, because normally the forward measurement should